So we're going to move forward with what we did yesterday and factoring the trinomials. I want you guys to realize that yesterday, today, and probably the next 2 days is something that we would have done all in one day if we were, in a regular school year. So what I've kind of tried to do is break this up into small chunks so you can focus on, the process and not get overwhelmed with what we're doing. So yesterday, everything that I gave you was positive. So you didn't even have to worry about, a negative integer. It was just everything was positive. So you had to focus on, what your numbers need to multiply to, what do they need to add to, so you can split that middle number. Now today is exactly the same, except I'm introducing the negatives. So you're going to have to stop and think a little bit more about how to arrange your numbers. Like sometimes you might have to decide if one number is positive and negative so that they add up to the right thing. And this is where it gets a little tricky. I'm not going to lie to you. If you're not real good with integer arithmetic, if you're not real good with multiplying and adding positive and negative numbers, this might be a little tricky. So just take your time. Don't rush through this. Okay. So like I said, we're going to start out exactly the same way we did yesterday. This is for a different lesson. So what I'm looking for here are numbers that add. I hate this pen. Add to 2 and multiply to negative 63. So just a real quick review of integers. If they multiply to negative 63, one of the numbers has to be negative, right? If they're both positive, they multiply to a positive. If they're both negative, they multiply to a negative. So I'm trying to come up with a pair, one positive, one negative, that multiply to negative 63. And I also need to get them to add to 2. So what you can do, if you're not real good with your multiplication facts, you can sit down and just take 63 and start dividing it by things. Okay, so if I'm going to make a list of pairs here. So 1 times 63 is going to work. 2 doesn't go into 63. 3 goes into 63 21 times. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 doesn't work. So what I'm doing is I'm taking 63 and I'm just dividing it by numbers until I get a hit. Okay, so I'm going to take 63 divided by 1. That works. So 1 times 63. 63 divided by 2 doesn't work. 63 divided by 3, that's 21. So that's my pair, 3 and 21. 63 divided by 4, 63 divided by 5, there's 63 divided by 6. You see where I'm going here? So then I get another hit when I take 63 and divide it by 7. That's 7 times 9. 63 divided by 8 doesn't work. 63 divided by 9 works, but I've already got that pair, 7 and 9. So real quickly, just with a calculator and a few seconds of your time, you've got a list of all the numbers that multiply to 63. So in this set here, there is a pair of numbers that I can play around with the signs and get to multiply to negative 63 and add to positive 2. Okay, so if it multiplies to negative 63, that means one of them has to be negative and the other one's positive. So I need to kind of play around with the signs and see if I can get them to add to 2. Well, just a quick look at the numbers here. 1 and 63, there's no way I'm going to get those to add to 2. 3 and 21, there's no way I'm going to get those to add to 2. They're too far apart, right? So when I add them, one positive, one negative, they're not even going to get remotely close to 2. However, this pair right here, 7 and 9, they're only 2 units apart, 7, 8, 9, right? They're right there together. So I need to kind of play around with the positive and negative of it and get them to add to 2. So the way that's going to happen is if I make the 9 a positive and the 7 a negative. Now, I'm not trying to oversimplify this, but seriously, go back and think, first or second grade, 9 minus 7 right here. 9 minus 7 is 2. That's where that 2 came from. But then 9 times 7, that's the 63. You've just got to be careful with your signs. So I'm going to go back to what we've been doing the last couple of days. I'm going to split this down the middle. The first half, I can divide out an n. The second half, now this is something that I hit on the other day, but I'm going to really kind of emphasize it a little bit more today. The second half, the 2 terms on the right, it starts out as a negative, so I'm going to have to divide out that negative. And when I do, that's going to make this a positive 9 on the end, which matches what was in the first set. So my factored answer is n minus 7, n plus 9. Okay, that's it. take a little time with the mental arithmetic of this. Okay, sit down and if you're not good with your multiplication table, make a list of all the things that multiply to the number on the end, and then figure out how to get it to add or possibly subtract to the number in the middle. Now I say add because 1 plus -7, but you're really, I'm sorry, 9 plus -7, but you really just are subtracting if one's positive, one's negative. Okay, this one's a little bit different. So I'm going to do the same thing. Again, this is for a different lesson. So again, I'm going to come up with all the numbers that multiply to 27. Now, a lot of people don't even bother to look at the 1 times 27, but you never know with the middle number. It might actually, you know, if this had been, say, 26 in the middle, maybe that is the number. 2 doesn't work, 3 goes in 9 times, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 doesn't work, and then we're back to 9. So this is it right here. Those are the only numbers that multiply to 27. So I need to engineer it or make it happen so that the middle number is -6. So it's kind of the same thing. How am I going to arrange these two terms so that my 6 is negative when I add these together? Well, I'm going to make that a -9 plus 3. And if you reverse those, if you do 3 minus 9, it doesn't matter. It's going to work out the same way. You're just going to have slightly different numbers as you factor, but when you piece together your answer in the parentheses at the bottom, they're exactly the same. So split this in half, take out an x minus 9, take out a 3, x minus 9. And again, if those parentheses don't match, you probably overlooked something. You might have screwed up a sign. What's in the parentheses after that first step should match exactly. So your factored binomials are x plus 3, x minus 9. Okay. The last one right here, same deal. Come up with all your numbers that multiply to 18. You can either do this in your head, or if you're struggling, I would suggest writing them out. 1 times 18, 2 times 9, 3 times 6, 4 doesn't work, 5 doesn't work, and then we're back to 6, which is the same pair, 6 and 3. So I need to make a pair from here add up to -9. Well, now here, this is a little bit different. My multiply to number on the end is positive. So I need a positive number that they multiply to, but a negative number that they add to. Again, with the whole integer thing, if they're both negative, a negative times a negative is a positive, and a negative plus a negative is a negative. So I'm going to use this guy right here, both of them negative. -3, -6. So my -9 goes to -3 minus 6 plus 18. So when I split this guy, take out the n, and -3, take out the -6, and -3. If the second half of this, after you draw that vertical line, if the second half of it starts out negative, you are always going to divide out a negative when you divide. So my binomials are n-6, n-3. I know this video is a little bit longer than the rest, but I really wanted to kind of focus on the positive and negative. So that's going to, I think that'll be a sticking issue if you're going to have one.